every single time I start a podcast, I go, okay. It's like, how else should I start it? Like, hello, everyone. Today is math. We're on example 2, not 1. Yeah. It's fantastic. Fantastic times. I don't know. I'm going to come up with a start. I don't know what it's going to be. You just wait. It'll be like, hola, or hello, you know? But it's always like, okay. And I do it and I can't stop myself. It's an addiction. All right. So divide x cubed plus x squared minus x plus 3 by x minus 1. What is the remainder? So we went over remainder theorem. Remainder theorem stated that if I take the factor, which is this one, that I'm dividing by, I hate this computer because the set thickness is set. If I take the x minus 1, the factor, and I turn it into an x-intercept root 0, which are the same words, right? 3 for the same one, 3 for one deal. And I plug it in or substitute it in for all the x's in the polynomial, I will get the remainder, right? That's what remainder theorem states. So we're going to go x minus 1 equals 0. I know you probably don't have to do this. We're showing the steps. X minus 1 equals 0. Add my 1 over. So x equals 1. So now, remember, you can't just be like, hey, the polynomial p of 1 is this, because there's nothing labeled as p, right? So what we're going to want to do first is we're going to say, okay, p of x equals x cubed plus x squared minus x plus 3, because this actual function isn't labeled to anything. And now we can actually go p of 1 equals, right, because we have a p. So we can go p of 1 equals, and remember, whenever we substitute in, we put brackets. Now, if it's positive, it's not going to make a difference anyways, but it's just a good habit that whenever you substitute, put brackets. So we're going to go 1 cubed plus 1 squared minus 1 plus 3. So we're going to get p of 1 equals 1 plus 1, which is 2, minus 1, which is 1, plus 3, which is 4. Now we know that if we write p of 1 equals 4, that actually is the remainder. We agree? But in grade 10, we were taught that if we plug an x value in, what are we always getting? When we plug an x into an equation, what does it always give us? An input gives us an output. In junior high, we don't actually know what input and output means, but we just do it. And in grade 10, we're taught, hey, they're x's and y's. So when we put in an x, we get a y. So not only is this a remainder and an x value, it's actually a coordinate on that polynomial, right? So this is also a coordinate. It's at 1, 4. Therefore, it's not an x-intercept. Therefore, I have a remainder, right? So sometimes they'll say, is this a factor? And you can say, no, it's not, because the remainder isn't 0. It's not a factor if it's not an x-intercept. And right now, when we find this out, if it's 1, 0, then that's an x-intercept. This one's at 1, 4, so it's not an x-intercept. We agree? So not only is this a remainder, it's actually a coordinate. So I'm going to write that just to remind myself for later if that's ever asked. So it is a coordinate. The coordinate on this graph is at 1, 4. But the actual answer of what they're asking us for is the remainder. So if I leave it like this, and this is why I want to explain to you. If I leave p of 1 equals 4 on my diploma, and I'm like, hey, I just gave you the remainder, they're like, I don't know, right? They can't take that as an answer because you didn't actually make it the remainder. If you box the 4, you have a fighting chance that they'll be like, okay, that's the remainder. But if you just leave it like this, that's actually a coordinate. It's 1, 4, just written in function notation. That's all that is, right? So you're assuming that they know which is the remainder. And we can't give marks to this because some people think the 1 is the remainder. No joke. Because when they write it out, they'll go, the remainder is 1. I've seen it on diplomas. So we can't, if you give us this, we can't assume that 4 is what you meant to be the remainder. So we're going to say the remainder is 4. What's the difference for 3 as opposed to 1 and 2 that we did already? Yeah. So it's a linear function, 2x plus 1, right? It's oh my gosh. It's 2x plus 1, and it's linear still, so it's x minus 1 and 2x plus 1. They're still linear. This one just happens to have a slope, right? So when we solve it out, we're going to get a fraction. We agree? So let's do that. So we're going to get, the factor is going to turn into a fraction. So we take 2x plus 1 equals 0, subtract 1. 2x equals negative 1. 5 by 2. People will say, do I have to show every one of these steps? No, you don't. However, some people flip-flop the 2 and the 1 by accident in their brains if they don't show the steps. So they'll say it's -2. You should know that it's not going to be, because whenever there's a number in front of the x, you're going to get a fraction. So if you're getting -2, something's wrong. But I digress. So you try this one out. So first off, you're going to have to write the p of x equals the equation. Then you're going to have to find p of -1/2. And I would try to do it first in your brains. Try and do like 1/2 to the 3. 1 to the 3, 1/2 to the 3. See how you go. Remember in university sometimes, a lot of the times, you take away your calculator. Often you're given a little one though at the very least, so you should just take away the bracket ones. Does everyone know where the fraction button is on your calculator? If you go alpha y equals enter. So on your calculator, if you go alpha y equals enter, it'll pop up a fraction for you. You can actually make it look like a fraction. So we could go to bracket alpha y equals enter, -1/2, bracket to the power of 3. So if you press the alpha y equals enter button, if you have a TI-84, if you have a TI-83, it's never happened.
Okay. Good to know.
Bad thing. So if you go alpha y equals enter, you'll get the fraction button. The very top left, y equals. Oh yes, I have had that happen. People will go y equals. So you go alpha, the alpha button, and then the y equals button right above it, and then enter.
I'm actually so good.
Fast learner. So I'm going to do it with actual fractions. So we're going to go to, when we do -1/2 to the 3, and the reason why we're going to actually go over this in big time, all the actual math, is because your AP test, half of it is no calculator. Half of it's calculator, half of it's no calculator. The good thing about half that's not calculator often doesn't use very much calculator, so you're okay anyway. So -1/2 to the 3. When you have any fraction to an exponent, you raise both numbers to that. So you can go -1 to the 3, which is -1, and then 2 to the 3, which is 8. And then when you multiply fractions, it's numerator, numerator, denominator, denominator. So it would be -2/8 or -1/4. You don't have to do this, but I'm just showing you. -4, so if you go -1 squared is 1, and then over 4. And so I'm going to get -4/4. I'm not going to reduce that because I can only add and subtract fractions with common denominators, so I'm just going to have to put it back if I do. And then here, I'm going to have -3/2. But I'm going to rewrite that by multiplying them both by 2 to get a common denominator of 4 as -6/4. And then this one's a -6, so I need to be over 4, so I'm going to multiply by 4, so I'm going to get -24/4. So -6 and -24 is -30, -40, -40, haha, -35. I couldn't even start adding because that was all bad. -35/4. And that's what is a decimal, sorry, negative. Well, it should be because it's going to be 32 and then 3/4. So -3/4, and then this decimal really actually represents improper or mixed fractions, because if I do 35 divided by 4, it's 32 divided by 4, which is 8, and then I have 3 left over, so it's 8 3/4. So your decimals are just mixed fractions. Yeah.
What's the good for?
So it just depends. If it's a numeric response, you're going to have to use decimals, and if it's anything else, I would always use fractions. Yeah. But if it's a terminating decimal, it's equally as good as a as a fraction, right? A terminating decimal. The problem is that sometimes you'll get fractions like a third, and people will go 0.3. That's not the same thing. Because if you do 0.3 and you go math enter enter, that is not a third. It's 3 out of 10, right? Or I guess, yeah. So don't round decimals unless it's asked for it in a numeric response. Okay. On the AP exam, the great thing about it is everything is rounded to 3 decimal places unless it's asked. I don't know why they chose 3 decimal places, but that's pretty cool. Okay, this one's a little different. It says, when x cubed plus 5x squared plus kx minus 8 is divided by x minus 3, the remainder is 1. So in this case, we actually have that k in the polynomial, right? And then they say, find k. Well, I know that if they gave me x minus 3 is what it's divided by, I can go x minus 3 equals 0, and I can say x equals 3, right? And my remainder is actually just my y of the coordinate, isn't it? So my y is technically just 1. So if I write this as a p of x would equal x cubed plus 5x squared plus kx minus 8. If I write it like that, I can actually write 3 and 1 in function notation, right? This would just be p of 3, and it would equal 1, right? This is just function notation of writing a coordinate. That's why you're taught function notation in grade 10. You just don't know it. It's like to help you for this moment in life. You know, you learn so much in grade 10 that you're like, I don't know why. And then it's like, here's the moment. This is why. So this is the moment. So instead of, we can write p of 3 here. We can do it in 2 steps. You can do it in 1. I'm going to do it in 2 to prove a point. So we could go p of 3 equals 3 cubed plus 5 times 3 squared plus k times 3 minus 8. We've done nothing different than the previous question. We agree? The only difference is I know that p of 3 equals 1. So instead of writing p of 3, I could write a 1. So I can actually set this as 1 equals, and then do this. 27. 5 times 9, 45. Plus 3k minus 8. That does not look like a 5, I'm too lazy to erase it. So you can always set your polynomial equal to the remainder, right? That's what you always find out as long as you have an x to fill in. So now we're going to get 1 equals, what's 27 plus 45? 72 minus 8? 64. Plus 3k. Subtract 64 from both sides. And I get negative 63 equals 3k. Divide by 3. And k equals negative 21. What's great about this? We can check every single one of these. Because what we're really doing when we're finding remainders is we're finding y values, which means we're finding coordinates. Do you agree? So I want you to go to your y equals on your calculator. We paid lots of money for them, so we're going to give to you. I'm going to make them worth their money. Okay, so in your y equals, I want you to type x cubed plus 5x squared plus, or minus 21x minus 8. Because we can put the minus 21 in for the k now, can't we? So in our y equals, we're going to go x cubed plus 5x squared minus 21x minus 8. I need to get a calculator on this one. It's on my one that the HDMI cord doesn't work. So that's off. I can't bring my calculator up on here. And if it's on the computer, I can't share. So once you type that into your y equals, where can we find coordinates in our calculator? Where can we find all the coordinates from the graph? Do we know? Go second graph. Go to your table. Go second graph. I'll show you 2 ways you can do this. You're going to go second graph. And you're going to look for 3 and hope it has what for a y value? 1. Does it? Yay. Okay, another way we can check it. You didn't get 3 and 1?
No, I got negative 8.
Okay, so watch it when you put this in. Go make sure you're putting in x cubed plus 5x squared minus 21x. Not negative 21x, because it'll be multiplication. So watch your sign. Sometimes it's the symbol.
Okay, can you?
Yep. And then I'll show you another way you can check it. Oh, that's right. No. Oh, it's plus. Yeah, it's usually just a technical. Okay, another way you can check it quickly if you just want one coordinate. So we're really only checking one coordinate here, correct? So we go to the table of values and we see a whole bunch of coordinates. Or we can check a coordinate. So every time we know an x, we can always find a y off of an equation by doing this. So you can go second, trace. Because what's the word behind trace? What's the little word above the trace? Calc. So when we go second trace, we're calculating stuff. Because that's where the calc is, right? So we're going to go second trace. And then whenever we have an x and we just want one y to go with it, so if we ever have an x value and I want the y so I can graph it, I can do this. So I can go second trace number 1, which is value. And what pops up? X equals. And what does our x equal? 3. Hit enter. 3, and then enter. What do we get? 1. So we know we're right. So you should not walk away from any question on this test not knowing if you got k correct. Right? Because you can type the y equals, you can type it into y equals, you can look at it, you can go to your table of values and look at it, or you can do second trace value. Now the second trace value is better for the fact that the table of values only shows you whole number x values, right? So if it was like a fraction, like that -1/2 or something like that, then you would want to do second trace value. You can also change your table of values to different values as well. So your table of values currently goes up by 1s. Yeah? So you can actually change your table. So we can go second table set. So second window. If you go second window, you can, do you see that little change in table? It's the delta table, which means change in if you're in any sciences. You can change that to 0.5. You can change that, and then it would go up by 0.5s. You can change it to 0.25, so it would go up by 0.25. And when I used to do this, I'll do it in 30-2 every single time, or 20-1 when I start showing where the tables are. I'll say the table will go on forever. Well, then there's always one person who's like, let's get it done. And they like hold their hand down for 77 years, and it's like gets to -1,000 on x, and like, see it again. If I don't teach them how to reset their calculator, or this little functiony thing I'm telling you right now, they literally have to hold it down until it gets back to 0. And I often let them do that. So I feel like you were really committed to making it go down here. But you see the table start above the change in table on that window? So if you went second window, do you see table start? That's where your table starts. That's what it's called table start. So those people who hold it down to -1,000, if they just go if they go second window and they go table start, they could just table start at -3 and poof, it'll be back. I often don't let them know that till later, but it's fine. So that's how you can run your table. All right. Does that make sense? Okay, you guys are going to try number 5. So we have given that p of x equals this, so we're going to do, I'm asking you, what was the factor if this is 3? What would the factor have been? This would have been x minus 3. And what else could they have said? Instead of putting the 12 here, what could I have told you?
The remainder is 12.
The remainder is 12. I will spend most of the year getting you to understand different ways to look at something, because the diploma can throw anything at you in different ways, right? So it's always 10 and 11 people can get away with a bit by memorization. 12 you have to understand, because they can throw anything at you. And as long as you understand, hey, this is just a factor, hey, this is just a coordinate, hey, this is just a remainder, all those different ways of looking at it, hey, I can check it on my calculator, all those different things, then I can throw anything at you and you'll be successful, right? Because you understand why. So we're going to go P of 3 3 cubed minus k times 3 squared plus 17 times 3 plus 6. And so we get p of 3 instead is 12 equals 27 minus 9k plus 3 times 51, I believe, plus 6. 12 equals 27 plus 51 is 78 plus 6 is 84. Subtract 84. Negative 72 equals negative 9k, so k equals 8. Did you guys check it?
I tried. I'm doing it in my brain. It's nothing is working.
Now remember, you can actually check this algebraically. Your calculator is literally just substituting the x in and getting a y out. It's putting an input in and getting an output, correct? So if you didn't have your calculators in front of you, could you not just put the 8 in for k and then put 3 in for x's and see if you get 12? It's the same thing. That's what your calculator. Every single time you're putting in an input, it's giving you an output. So if you're putting an input in and getting an output, you could do that in your own math. You could do that algebraically. You wouldn't need a calculator to do it, right? You can put in an x and get out a y. So every single time you're going second trace value, or you're going to your table of values, you're literally just looking at inputs for outputs, which means you could do them algebraically. Your calculator's just doing it quicker. That's all. Okay?